Hey,
Hey.
it's 8 minutes past. This is a clapping to synchronize the sound, and I am welcoming every one of you here to my little session, which is called Information Visualization 1 Hour Introduction. The purpose of this is to basically compress my entire knowledge of data visualization, which I've been acquiring for over a decade, into 1 hour. And hopefully then you find it useful, yeah? So a bit about myself, so like how did I come to this room and what is...
I'll just take a picture.
What's going on? I'm Andrew Yurt, but I just keeping this for you so that you have like a nice background for photos. I'm Andrew Yurt. I grew up in Russia. I studied at this Ural Federal University where I did a program of industrial automation and control systems. I then continued and did my master, it's engineering thesis at a factory which looked like this. So my software was controlling these motors. And here I'm using a laptop to upload this software to a programmable controller at the factory so that it can tell the drives where to start and stop and all that. So here is another thing that we did. So part of our project was setting up these screens for the operator user interface there. And the operator here would be in the room. Here's the old system on the wall with a bunch of lights and like representations of the factory in very limited ways. So you would just have a lamp that says this thing is on, this thing is off, yeah? And then the operator would use this visualization on the screen, which was adding or replacing the thing on the wall to be able to monitor the factory in a better way. I see all sorts of like operational parameters, start and stop the machines, and do similar things. Yeah. So as operator needs to do. After that, I found these user interfaces really exciting. So I thought, okay, I want to study that a bit more. So in 2012, I went to study in Sweden. That's where I met Caroline.
Yeah.
I studied at the school where she was working. So back then I came to Sweden to study a master in human-computer interaction and design, which led me to do my industry master thesis at ABB in Sweden. This is how parts of it, how it looked like. So I was exploring data visualizations for alarm monitorings in oil platforms, of all things. And this is the result of my thesis as like a single picture. So here would be like intensity of alarms, and here the person who is analyzing what went wrong, maybe there is some unsanctioned situation that was happening at one of the oil platforms, could go in and look for the root cause of what went actually wrong, and if we can remove some of these alarms. These alarms are problematic because usually the operator would get like a flood of them, like hundreds, and then like, what do I do now? And then there's the overwhelming stream of information to the operator, and the operator doesn't not able to do anything more with that. So analyzing them and bringing down the number of alarms is considered a useful thing, but a hard thing because can I really remove alarms? It's a bit of a legal and technological, legal and other kind of considerations. After that, I left the corporate world and I joined a place called Gapminder Foundation, which is really extremely different from the corporate things that we did previously. You've seen now it has all these like colorful charts and visuals, and in a very playful style we use toys to visualize the information. and styrofoam blocks and printed maps and whatever. This was our team back at the time when I was working there. So I just left recently, like 3 weeks ago, to be able to start my own company and do the same thing, but just as a business. Some random facts about me. I like mountains. This is me in Norway looking at probably some kind of maps so that I can figure out where to go next. It's in Jotunheimen. So to go to mountains, I need to pack my things in a bag. And I used this spreadsheet, which I made in a Google spreadsheet. It has a function where you can make the cells show like little bars for the numbers that they represent. And here I look at the different weight of all of my items. So I put all of my items on the scale. I weigh them and I discover that, okay, this thing is like not really, it weighs unreasonably much for me to take it with me to mountains and carry it for like 100 kilometers there. So then I can like be informed of getting rid of things. And like being informed is one of the use cases, or like one of the reasons we do data visualization. And it doesn't have to be complicated to really find out the insights that you're looking for. Here I just have a bar chart, which I made in a spreadsheet software. If you use Microsoft Excel, it also has a button to make those. So, and then I go to the tunnelbana so that I take the tunnelbana to a place where I'm going. And then I look at the timetable. And it looks like this. This is called stem and leaf plot. So this is a technique from data visualization. This thing is called the stem, and it shows the hours where the trains would depart the station. And these things are leaves. They show the minutes when the trains depart the stations. So if I'm close by and I'm looking at these numbers, I'm like, oh yeah, it's 1718 and 1723 and so on. There's some footnotes and stuff, but I can like analyze that data and read it and understand when the train would leave the platform. At the same time, if I'm standing far away, you can kind of see the histograms here. You see more trains in the peak hours in Måndag, Fredag, and then in the weekends there is like a more even, without the peaks so much pronounced, but also fewer trains. So these are the techniques that we actually use. You want the techniques and general principles of data visualization, so here you have them. Then I go to the mountains. I have a weather forecast because I need to know the weather to climb a mountain. And then it looks like this. I want to climb this Soliskungen. And where was I? I was here. So this is the only day when I had the time because I was in the area. That was the day when I had to climb it. And I woke up early, of course, and I started going. And the forecast was like, fog. And then by the middle of the day, the fog should have disappeared. So here I have a little, we call it stream graph, or it's like a layered area chart. You have line charts, you could turn lines into areas and you can layer them up, then you have stacked area chart essentially. And this shows clouds, so that shows like the fog, and then there's like heavy clouds, low and middle and high clouds here. So then the fogginess here should have disappeared. And I was counting of the sun to shine there. You also have like temperature and the rain that is possibly coming in the evening and the wind speed and everything. So you have like a lot of information in the same view, and then you could do like informed decisions by just looking at it. It's from Yr, the Norwegian, the best one we have, meteor service. And then to go to, I wanted to climb this line, the red line that I drew for myself on the map, and I wanted to climb this one. But I also had an alternative line which is depicted in green, and that line is tracked by someone else on the map. It's included in the map. And if I make a line here, it can show me the elevation profile, the slopeness, so I would know where it's like hard to go up and where it's like dangerous to go down and so on. But I wanted to take the red one, and you see, like, I'm using my vision to think, to assist me in thinking. Like, my brain is like so limited, but if I have this information visualized, then it's less limited, and by doing that I kind of extend my thinking tools. Yeah, that's the whole idea of what we do. So I went through this red path, and I was hoping to the fog to disappear. At this black cross there, which you see, there I couldn't quite tell if I'm like on the glacier, which is shown here in this area, or I'm on the snow, and the visibility was like this. The fog didn't disappear, so it was like 5 meters forward I could see, and I was alone. I'd never been there, and I didn't know if I'm on the glacier or not, because that could be dangerous. If the glacier is covered with snow, then you don't know where the cracks are, and also it's foggy, so you can't see them. And then if you fall through the crack, then you're like so dead. So I wouldn't want to be that much dead. So I was like walking by the edge of that snow patch until it got difficult, and the fog didn't disappear. So then I was like, this was my face. I wanted maybe. I did get some mobile reception though, so I could send that portrait to people following the journey. But then I had to go down and take the green line instead, which was. Sometimes it's a smart choice to not climb a mountain in the fog alone, the one that you've never climbed before. So it's 3 factors that tell you to go down. Another example. This was just like a fun introduction, yeah? So this is why we visualize the data. I have a bunch of numbers in a table, and they're divided in 4 different groups. Group 1, 2, 3, and 4. So each group has 2 columns in it, and each column, here in the bottom I have summary statistics for each of the columns. I have the mean, the variance, the XY correlation, and I have the linear regression. So those would be the things that you researchers normally compute on data when you get a bunch of data from your research project. And those tell you like things that you want maybe learn about your data set. And as you can see, 9999 here and 75. So all of them numbers between these 4 different categories, they match exactly. Do you know where this is going? Have you seen this data set before? Yeah. Okay, I see one. The idea is that this data set is artificially constructed to just make a point that the summary statistics that you have here, and they're matching all the 4 groups together, they can result in very different pictures if you actually visualize them. So this is like constructed in a way to have them summary statistics equal, but the pictures are very different. That's why it's very important to see if your distribution has 1 peak or multiple peaks, if you have outliers. Maybe your outliers are due to like some crazy measurements, errors in your tooling or whatever you use to collect the data, or maybe some of the people who are the outliers, they are actual outliers in the society, and then we have to make all these choices. Do we throw them out? Maybe they're just weird people, and we shouldn't throw them out because then we exclude them. Yeah. So. What I do is data visualization, and of course everyone puts themselves in the center of things. I do here that as well. The center of things being different disciplines or different, what we call them, areas of expertise that are overlapping at this data viz kind of activity that I'm doing. And those being the user-centered design, that's what I studied at KTH, the cognitive psychology, the art, and the computer science, of course. So now my lecture starts, really. So I'm structuring this lecture around, going around the circle, in different circles. And I'm going to show you like a few things from each of these areas of expertise that come together in data visualization and how they help us understand data through visuals. Yeah. So I start at the top with user-centered design, and I'll just keep it like quick because we don't have like too much time. But if you feel like you want to learn more, each of them 4 areas and deeper could be extended into like a special lecture if that's something that is of interest. Okay, so the user-centered design, here is the foundational book for that area of expertise. Donald Norman, the design of everyday things. I have my ratings for every book, and that's how you know I recommend that you read it, because you have the rating there. I'll share the slides later so that you have all the references to the books where to look further and so on. So that book introduces us to a few of these concepts from cognitive psychology, namely the mental model, system image, gulfs of evaluation and execution, affordances, signifiers, and constraints. What is a mental model? A mental model is an interpretation of how something works and can be used. I have the example here, which is the washing machine, but imagine this is a chart, yeah, or your research paper results that you try to communicate. And you as a designer have a designer mental model in your head. You are deep in the session, so you know what it's all about, and you know all the nuances. You know how things correlate or cause each other or whatever. Here's the user who would be reading your research paper or using that washing machine in this situation. You can't communicate directly, and that's the thing that why this expertise is needed, because the only thing you communicate is through something that's called the system image, which is all the knobs and buttons and labels on the washing machine and the user manual, which nobody reads. And that's the only thing how you could communicate. So your task is to compress your very rich mental model that you have about whatever you studied for so long into a paper or whatever user interface that you have here, and then hope that the user would be able to uncompress that model into their own brain and upload it back, and that mental image mental model that would form here in the brain of the user would not contradict the reality too much. That's the whole point of it. So how can we do that? We do that in order through affordances and signifiers, then constraints, then state presentation. If all that fails, the user will start using labels. You see how deep they are in the list, how far they are from like being able to actually describe and define what you're trying to show. The manual is like even further. So if everything else fails, but not even then, because then the user would just give up and do something else instead. If a mental model doesn't match the reality, it leads to frustration, anger, and human errors, sometimes catastrophes, but most of the time it's just not being able to open the door because you try to pull it when it needs to be pushed, and that's when the design fails. That's how you know it. So the gulfs of evaluation and execution, what are those? So those are the sources of the frustration. The gulf of evaluation is not being able to tell what the thing is doing. You look at thing, you have no clue if, like, is my page frozen? Is it working? Is it worth waiting? I don't know. Like, maybe I should refresh the page. Maybe I should go drink some tea. I should drink some tea. Maybe I should do something else, yeah? The gulf of execution, on the other hand, is when you don't know how to bring your system into the desired state. Yeah, so how do I do the thing that I need to do? Yeah, so if the two gulfs are large, that leads to a feeling of disempowerment, like I'm not smart enough. Maybe you felt like sometime with some technologies or whatever, I'm not smart enough to use the washing machine or the flight booking page or the chart or whatever, yeah? Exactly. So affordances, these are the best friends to bridge these gaps. How do we bridge them? The affordances is a quality of a property of an object that communicates its possible uses or make clear how it should be used. Yeah, affordance is not a sign. It's not a label. It's not anything that you write on the thing, whatever. But it is coming from a deliberate design practice. And affordance is a quality of an object that it presents itself, such as a chair has a flat surface, which is roughly the shape and size of my ass, so that I can sit on it, as opposed to a table, which also has a flat surface, but it's like different height, it's differently like different materials, maybe different like size of it, like all of that communicates that this is not for sitting, even though it could be used for sitting. Yeah, some things are better for writing than other things. Yeah, even though they're both flat and both like evenly colored, but this is not structured. This is a bit more structured and rough, so I wouldn't write on this one. I would write on that one. Yeah, and more of these examples. A door handle shaped to be pulled, so I would pull that one. A button is shaped to be pressed, but this is not shaped to be pressed, this is shaped to be turned. And this is shaped to communicate that it has two states, like two states possible. This is a weird shape, so Uber has to send a push notification to you if you book like a Tesla taxi and tell you how do you open the door in the Tesla. That's how you know the design has failed, yeah? If that's needed. You need to manual to open a door in the car. Let's do an exercise. And then signifiers, that's the other word, but I don't make too much of a distinction between signifiers and affordances. Signifiers just help you to discover the affordances. So this is a mystery device. Please tell me the affordances and signifiers that you see here.
There is a button that is red.
Yeah.
This one. The color.
Color. So button that is red, like what's about that button?
Feels like you need to push it.
You mean that
Yes.
one? It looks pushy, right?
Mm-hmm.
It looks like first it has a dent for roughly like a size of a finger, mm-hmm. So like it's pushable. And also you see how it's like screaming at you that it's in an interactive element there. Okay, more examples here.
So right above is the handle, so that you understand that you're gonna hold it that way, and then push with that finger.
Or that way or that way.
I was thinking about the one to the right now, but both.
But both actually.
Yes. Yeah.
And they are not red, but they are like shaped roughly in shape of your hands, like they're grabbable. And they're also covered with rubber to assist the grip. And it's also, they don't tell you that they are interactive. So by not adding the red color, the designer shows that these are the static elements. And so on, we can find more of them here, but you see how the world communicates with you in through that design here. So I'm an interactive element. Turn me here. I'm good to hold me. Yeah. So those are the affordances, and I hope it's enough of an example to for you to carry it further. Constraints. These are kind of the opposites of the affordances. These are qualities or properties of objects that tell you how not to use them. So they limit your space of possibilities, and by doing that, they reduce your mental effort. So these are like the different. They have different types, like how Legos fit together. Those are physical constraints. And there's like logical constraints. If you reach the end of the page, the scrolling stops. Yeah, but it's nothing physical in that. We just made it up so that the scrolling stops there. Semantic constraints, the cultural constraint. I have an example here. The cultural constraint. I was trying to book a flight with Air India, and it told me to like choose a title for myself, which should be like Mr., Mrs., Doctor, Lord, Lady, Rev, Prof, Capt, Sir. I was not prepared for that much of choices. It's also a mandatory field. I was like, I'm a lord now, okay? Yeah. This one shows an example of a logical constraint in the sense that the left switch should operate the left light and the right switch should operate the right light. That's how you know this, the mapping here helps for you to find out which light you can switch on and off, which is never observed in our rooms in this. You try all the buttons until you find the right configuration. That's what you do. And then there is the semantic constraint of up meaning on and down meaning off, like light is up, down is off, but also not everyone follows that constraint, because I know some electricians, they just down is like, I don't know, I press down, whatever. But light is on usually, or should be. Okay, so good design is, it gives you a system image that doesn't contradict the reality. It helps to build a useful mental model, reduce self-evaluation and execution. Affordances and constraints are your best friends. Labels as a backup, and forget the user manuals. So this was a quick summary of the user-centered design section. Now we get into visualizing data. I have a map here of my entire course that I'm giving my students every semester, and this is the entire course basically, and this is a pipeline of how the data would travel from raw data into the data tables, into the visual structures, and then finally the views. So all of that is made for a user. So a user is here, a user has a certain goal, like I have an example here with Frodo, who has a goal to like destroy this ring. So he's looking at the ring, he needs to destroy that. In order to do that, he needs to dump the ring into a volcano. That will be the task, to get that ring into the volcano and dump it. To do that, he needs to do a subtask to navigate to the volcano. And that's the context, right? You see all that happens in context. To achieve that task of navigating to volcano, maybe he needs a map, maybe he needs a navigation, maybe he needs a GPS, whatever. So you provide the tools with your charts to solve these tasks, to achieve these goals in a certain context. And the context here is important, because if you understand this, you would choose smart between the light mode of your map and the dark mode, yeah? Because in the light mode, the phone would shine too bright and the orcs would find out easier about Frodo moving around. But so you want the dark mode, yeah? And you need to provide like useful map for a useful place. And maybe Frodo doesn't understand the map, okay? And then Frodo would go there and change visual mappings from the actual map to maybe turn-by-turn navigation. That's where you can say like go left, go right, and so on, yeah? So if the user is not satisfied with a tool solving the tasks, the user would dive deeper and deeper and deeper until it is solved, and finally getting to like different data set. But the deeper it goes, the harder it is to do. So this would be like zoom, rotate a map. Here would be like switch the map to turn-by-turn navigation. Here would be like get the map for like different layers on the map, filter different like terrain or whatever, roads. And here would be like, oh, I have an entirely wrong data set. I have entirely wrong map. I should download a different one. Okay, that's the idea behind this picture of the entire course. And we need to define what a good data visualization is. And the definition of a good one is just following these things and expanding them. A good one is one that deploys high quality data, so that's here. Relevant data transformations, visual mappings, and view transformations to enable certain users, that guy, perform certain tasks to achieve certain goals in a certain environment, in the context, yeah? And then you can measure these quality criteria of how well it does that. So effectively, which means accurately and completely, efficiently, which means how quick and so on, and effort versus benefit, easiness to learn and retain the learning, and with satisfaction. So all of them you could measure in user testing. Actually invite users, observe them, give them tasks, how they use your technology, and see if they succeed, and probably they don't, then how to make it good. The next slide is how to make it good. So you go back and redo the whole thing. Yeah? So after you've evaluated, that is the testing with users, you go back to your requirements, you adjust them, you redesign the thing, you implement. So that whole circle is easier to do if you make low-cost prototypes, if you test early and often, if you pivot, if you don't see that it works, but something else might work that is related, and then do the cycle multiple times. So if you don't get bored or depressed, eventually you make a good product after some time. But it does take patience to go through all of these things. Okay, I skipped one of the slides here. It's like a hierarchy of goals that the user has, or goals and tasks. So the goal on top here is ultimately like to desire to survive and thrive, as we all have as humans, yeah? But the high-level tasks, they would support that goal of the user directly, yeah? For example, I want to provide analysis of my market research so I can be competent at my job so that people respect me. That's how I survive and thrive at my work. Yeah. So then you assist that whatever market analysis with mid-level tasks, identification of trends maybe, or pattern recognition or forecasting, whatever. So those are like already like we're getting into the information tools here, such as charts. And then there's a low-level tasks, finding maximum and minimum, finding outliers, and so on and so on. So I have some examples here with actual charts. This one that is frequently presented in data visualization. Who've seen it before? Henry? Yeah. Okay. So this is a story. It's a chart about the story of Napoleon army. So remember, like back in the day, Napoleon got a lot of soldiers, namely 422,000 soldiers, and marched all the way to Moscow to take the city, so that he wants to conquer many countries on the way, and then Russia eventually. So and he took Moscow. But then the army that he had, it was only 100,000 soldiers when he reached Moscow. And Russians, they've abandoned the city and they burned it so that they wouldn't get any supplies there. And the only thing they had left to do, it was winter, it was so cold, they were freezing all the time. So they had to like retreat from back to where they came from. And all retreating, they kept losing soldiers, troops. They've reunited with like part of the troops here. They've lost a lot by crossing this Berezina river in modern territory of Belarus. And then they've come out with only 10,000 soldiers. So, do you see how this visual information tool is telling a story? So I'm able to track the whole campaign kind of steps in it. What the stories do, they give us steps, so we can follow the steps here. Yeah, so it goes like that, it goes back here. And on the way back, there's also matched with like temperature scale. It is in French, whatever measurement, Rémoire.
Yeah, that's just a type of thermometer. So it's just like the name of the thermometer.
Yeah, it's but it's like different numbers in it.
It's degrees.
It's degrees,
Yes.
but it's different degrees. Like it's not Celsius.
Yeah.
But it was cold. It was. I have this chart in Celsius as well somewhere else. But this was so cold that they were like freezing and dying all the time. Let's analyze it a bit more. So from the overview, you see that there is like a thicker line going in and a smaller line going out. The overview is one of these tricks that you would use in data visualization, which gives you the ability to see the whole thing at once in a way, and that's the power that it gives your brain extra powers because you can see the whole thing at once. You can see the whole story at once, how it starts, how it ends, and so on. But then you could dive in, just how we did in stem and leaf plot with train time departures, timetable. You could dive in and you could see this Berezina river crossing disaster and other river crossings. So those would be the details which you dive in and then you learn more about whatever you've just seen in the overview. Okay, so that's telling a story. I'll show you something completely different now. Let's look at the different task that data visualization may help solve. This is a monitoring task. So in the monitoring, this is called SCADA, so Supervisory Control and Data Acquisition. This is a representation of a heating system in some kind of building. So a building manager or like whatever building operator, like a large office building, whatever, would sit in front of a screen and look at these like boiler, radiators, whatever, and see if everything is like working all right. There's like some flow this much and temperature this much, and then it could switch like pumps on and off here. Yeah, it looks very different because it solves a different task. Now we're not telling a story. Now we're just like optimizing for sitting like this, and then if it's like something bad, it should be very visible here. Yeah. So see what's up, get alarms, and remote control. Those would be the subtasks that would assist this. Yeah. Another example. This is my kitty, and I put the GPS tracker on her so that I can see where she's like going out in at the farm and like bullying other cats. So this is our farm, and this is like how she travels in one day, and this is like in a few days how she traveled. So this is the farm, and I can see that she's hanging out at the neighbor's farm as well quite often, and then a bit here and a bit here. So and quite some times here. So again, a different user task. This is a discovery user task, so it helps me to discover some maybe interesting facts about my cat's behavior, so where she's hanging out. Yeah. I have another one. Which task does that chart solve? I just had to throw in an example when a chart doesn't solve any task, and that's when you get this. So you see I'm not starting by telling you that this chart is bad. I'm starting by telling you a chart needs to be a tool to solve some kind of tasks that the user has. And if it doesn't solve that, if you don't have a task in mind, then why you make it? So this one is so useless that it's what do you even do with it? All right, and somehow people have this affinity that people want to make circular things all the time. So pie charts are really popular for like no specific reason. However, I have a task of sleep data analysis here, which are also circular. This is like bedtime start, a bit random, but like clustering around midnight. And this is bedtime end, so this is like when you wake up. Now it does make sense to put them on the circle because time kind of moves on the circle like every day. So then you see how the alarm goes at like 7, 7:30, 8. This is very common alarm time. So you see the brighter alarm times as you throw the data here on a visual structure that really supports the task that the user may have with it. One example, the other example. Cool. Okay. We have like 13 minutes. Are we like good? Yeah. Let's do another topic. Because I don't think I'll cover all of them. It's a bit Or maybe let's do this thing. I'll skip cognitive psychology.
No. No.
Let's plan that for a different session because it's super cool and interesting and it does deserve its own.
I accept that. Justification.
It's cool and interesting. Sounds good.
It deserves a thorough, more than 10 minutes recognition, I'd say. But in 10 minutes, I can package some computer science, I think. So let's learn. Now we learn computer science in 10 minutes. Cool. So now I'm introducing some memes. And the first meme that I'd like to introduce today is called tidy data. So you've maybe heard clean data, but like tidy data with capital T, tidy, is something that researchers have come up with to represent data in a predictable way so that it can be visualized easier with different tools. What is it? Tidy data needs to follow, or by definition, it follows these three requirements. Every row is an observation, every column is a variable, every cell is a single value. If you create a data table which looks like this, and that data table matches these requirements, it follows them, then it is a tidy data that you've made. All right? And some of the examples when that requirement is broken is, for example, do you see how like Brazil, urban, rural, this one has 2015, 2016 in columns. So there you have multiple observations in a row. Yeah, you're not supposed to have that. Here you have vaccination, urban, vaccination, rural. Here every column has like multiple things going on in there. So every column is not a variable here. Also, it's like two observations in a row again. Here, down there, Brazil urban is again multiple things in the column. And then the indicator here is vaccination. You could have like population in the next one, yeah? So that would mean a column is not a variable any longer, and instead you would try to package multiple variables in the same column. So this, like all of them things here, that's how they are not tidy, and then the one at the bottom is the one that is tidy. So that's the meme. Yeah. Another meme is something that we call dimensions and measures in the data. Dimensions are the things that define your characters, like they describe what you're talking about. And measures, they define what new do you learn about your data. So here the dimensions would be country year, country, rural, urban year. So all the pink ones would be dimensions. So they would identify what the data is about. And the green ones, they would be measures. It is a bit like abstract concepts from computer science, but and it is a made-up concept. So we just made it up to help us organize data tables. But the idea behind these dimensions is that they would uniquely identify the rows of our data table, of our tidy data table. That's how we know they are dimensions. If we remove one of them columns here, like remove year, you get Brazil, Brazil, and then now you don't know anymore which one is vaccination in Brazil, so your table got redundant. Remove country, and you have 2 years with 2 different values. Now you don't know like which one is which again. So that's the test of how you can tell that this is a dimension. Okay? So there's also like dimensions, they are the independent variables, measures are dependent variables. So you've maybe heard that terminology, but it's the same. It's the same thing, really. So yeah. Next one. So now it's time to make the pictures of it, and remember it's a speed run. So we just do a very fast-paced overview of what we do in data visualization. Essentially, we make pictures out of numbers. And we do that by taking our data table, which is supposed to be tidy data, yeah? And then we declare that we represent each of them rows with a mark. And then we declare that we represent each of them columns with a aesthetic of that mark. That would be something we call visual encodings. And then for each of such representations, we come up with a scale. A scale is a rule of how we do the encoding. It can be like a function, linear, maybe logarithmic, other scales, you know. Yeah, categorical scale, maybe quadratic scale, or whatever other scale that you could use. Yeah, so those are the 3 steps. That process is called visual mappings, and it sits at the heart of data visualization. Marks would be the geometric shapes and symbols that you throw on the page, and the encodings would be things like position, length, color, area, volume, and so on. Yeah? So the scale here would tell us that the position here in pixels should match this amount of money in dollars. Yeah? So the function that converts dollars to pixels is the scale that we're looking for. And then maybe my countries and my categories would be converted to some of the colors. That's my categorical scale. And then the area depends, like I can't change the area on my computer, but I can set radius of the circles. And area changes quadratically with the radius. That's why I need the square root scale to compensate that visual change, because the visual change needs to be proportional for the data change. That's another principle for data visualizations that are useful. Yeah? And it's coming from that book, The Grammar of Graphics. The idea of grammar of graphics is that you could build data visualizations as sentences. And you could put them together with characters, and they're something you learn about them. And through that, you learn about the data. Yeah. So here's about scale that I already mentioned. I just wanted to point out that this is a weird choice here when they've put exactly which countries directly import the most Russian natural gas, and then the top is percentage of gas imports out of total imports. So the hundreds, of course, are the most dependent, and the lower ones are least dependent. And then the amount of imports is the size of the circle. But then on the x-axis, they've just arranged them alphabetically as like A, B, and C. So B for Belgium and A for Azerbaijan. That makes little sense to me. I don't know. We could have some other useful information here on the scale. But it is a scale. So they've come up with a categorical scale that maps to country names. And that's the choice that they make. Yeah.
They could have gone by continents.
Yeah, but the color scale here is like already used for Americas, Asia, Europe, the continents. Yeah.
And maybe it's like if someone's looking for a specific country, it's easier to find it that way.
Mm-hmm. Yeah. Let's look at the tools that you could use for making charts. Yeah, because you also want to learn some tools maybe. So I have a compilation of tools here, or not me, but there is data visualization resources. I don't know. Yeah, there's a charting tools, there's a coding tools, and you see there's many of them. Complex and mapping, and this is just a reference link where you go and you find inspiration. Mm-hmm. There is a couple of minutes demo about the software called Tableau. So Tableau is what's good about it is that it is a button pressy kind of software where you press buttons and the charts like magically manifest on the screen. And you don't need to learn any coding to do that. So if you don't want to learn coding, that's a tool to use. Yeah. There is, see, I have like no code here. That's how you know like different level of coding involvement that you need to possess. There's low code tools. That's when you are willing to learn some coding, and that's we use with our students. We use the observable platform, and with something that's called the observable plot. And here again are the examples for the observable plot. If you press here, yes. Many examples like bar charts and heat maps and all sorts of things. So, like radar chart, you want to use that. So what's very common in our field is that you find a chart that you like, you see how it's made, and this is how it's made. You're like, okay, good. So where does it take the data from? Then you from here you figure out that the points are like the data that it takes in. Then you expand that. You see like iPhone battery life, iPhone brand, and like so on, like different criteria. Yeah, whatever. So you see the points. Maybe I can make like a data table to show really. This is like name and key and value. So this is how your data should look like, so that you could use it in this chart. And once you can arrange your data that looks like this, you can copy this thing by pressing the fork button here. So that's how you like copy it to your own account. And then you take, instead of that file here, you plug in your own file, and which has the same shape as you've seen this thing has, and then it has your data in it. And that's like the most common way. So we don't write charts from scratch most of the time, yeah? We don't need to do that. We find an example we like, and we make our data fit, and we just use our data in the chart that we show. And then there is the deep coding tool, which is called D3JS. You could also use that on observable platform. So a platform is this website where you can like do different like things, and things would appear. And then you could use different libraries on that website that you could play with. And it's collaborative, so you could use it as Google Docs. So you have other cursors of your teammates appear, and you see how them are sessioning the same code as you are doing, and there is the result of your collective effort. Yeah. So, and then I have more. Then I have like an overview of different tools, and here they are organized by if they are flexible and not flexible, and if they're easy to learn and hard to learn. So I have like Google Sheets, which is easy to learn but not very flexible, yeah? Excel there as well. And the observable plot is all the way up here. So it's like not much harder to learn than Excel, but it's much more flexible, you see? And it being blue, it's like charting libraries, it's like more like a coding thing. And then D3 is all the way up there. It's very flexible. It's what allows me to build all the charts I do at work, but then it's hard to learn because it's deep coding that you need to do. Yeah, so that's like the overview. And then let me conclude this session. Can we like stay 5 minutes more? So yeah, it's all right, everyone? Yeah, so I conclude the session by looking at the artistic part of my overview that I was showing you in the beginning. So this is a data visualization of books. I didn't make this. Someone read in 2022, and you've seen how it's nice. Looks like a flower, and it starts with like the day I started the book, and this was like a very long kind of reading time. The day I finished the book, they are arranged by months in a circle. And they are colored by different genres of the book. Yeah, so you see how it's both informative, it solves the task of someone learning about themselves, and it's artistic at the same time. So it is a way to express ourselves through data about ourselves. Here's one example that is not so artistic and one that is much better. Export of bananas in tons. So here is a chart which I tell my students not how to do, yeah? And then there is a redesign of the same chart, which involves some degree of artistic choices with design and so on. So that is another meme that I wanted to share with you, is to maximize data to ink ratio. So it's the data to ink to total ink used in the chart. So if you, here's like a comparison of the two. Here's a chart that is stuck in the heavy grid, and there's a lot of ink that is used for not data. And here's the other chart with the redesign. It's a bit of an extreme example. Like you could at least have an x-axis here. I don't know, but this chart is have a higher data to ink ratio because it mostly shows the data and so on. Yeah. So that is the combination of different areas that we've looked at. We did skip cognitive psychology, and it does have its own memes about how to make charts and how charts would benefit from our knowledge in cognitive psychology. Maybe we can run a lecture together at some point. I don't know.
I'm thinking for having you as a guest lecturer in my lab, so that I have nice.
Sure,
Design.
let's go. But that could be like a separate session,
Yes.
as I say. And I would like to end here with this picture. So what is data? The data originates, the word data, it comes from Latin language, and it's coming from like religious sermons. Data is something that is given, and there it is used like as a gift, as a thing given as a gift of God. Here I have a DMT God here on the slide. There. So from there, the definition has though drifted quite significantly from a thing that is given literally by God, from the most true thing that there is. It went into our math problems, right? So when we do math problems, we have things given in the problem, then we have things we find out by solving a problem. So this is like we change the definition of data. Now it's something that is true but not given by God, yeah. And now we change that definition even further. Because now we have social data, we have data privacy, we have data sentiment, we have data about gender, we have data about like identities and so on. We have data humanism, and I put the logo here. This is data vandalism, basically an artist project in New York City that use data to create social impact, and that's their way of using data. So the definition is drifting all the time, and you see how it drifted from a thing given by God through the thing that we do science upon to a thing that is part of our lives, and that's how we that's how we evolve, and that's how the data work evolves. Here I have like a little bunch of colors on the side. These are the levels from Ken Wilber model of levels of thinking, and I have a reference here which with a video. It's like 1 hour long video which you can watch and learn about these levels. But basically most of the data work that we do today is done on level 5 to achieve the scientific level. Some of it ventures towards understanding level with social justice and inclusion and so on, and some of it is done on the belong level. That is when it is used for things like controlling the population so that they behave, in authoritarian societies. So, but the idea, at least my idea, or the one thing that I wanted to inspire you doing, is to bring yourself and society to higher levels of thinking, as here on the scale. You're not at the level, yeah, so you are developing ways of thinking that are higher on the level, and then you like develop skills of thinking in higher ways, yeah. So level 8, I don't know if it's even possible. This is like some conceptually kind of hard level which I don't even have cognitive capacity to process. Level 7, I kind of get what it's all about. So, and it's definitely possible to make data work that would help us get there, and each of them levels solves the problems of previous levels. That's how they evolve, that's why they evolve. So this is the message, the boodskap that I have to you, and then here's the books that I use in my lectures, so it's like more book recommendations. And if we have time, we can go into my student projects that I can show to you and share what they've done. Otherwise, this was the lecture. Thank you for coming.
Thank you. I think it might be better to make sure that we have another session.
Oh, is it?
Properly.
I didn't know there's another one. Yeah.
Yeah, like down the line, I'll book you again. And then we'll continue on this topic, because I feel like it's a pity to kind of rush.
Yeah, it was a speed run, isn't it?
But it's
No, it's
so
super
good.
good. It's really good.
Yeah.
So
Thank you
good.
so much.
And you really brought it to a level that we could understand it.
Yeah.
Like I understood what you were talking about. So it was actually really inspirational, and I got a lot of associations to, things around me.
No, I'm bringing you up the levels.
Yeah, exactly.
Not this down the level, I bring you up the levels. That's what I do.
Are there any questions or comments from the attendees? Leader? No?
Okay, thanks for this. Yeah,
Thank you.
like and subscribe.
Yeah.